Welcome everyone who's just arrived in this room to the second session of the afternoon about developing with this Couchbase Mobile 2.0 API. So as you may have heard, the team's been really heads down for the past few months implementing a whole new API from scratch. And today we want to show you how it works in a real case scenario. So to have some interesting data to use with the API, I'm going to use a pre-built database that has a list of tasks, and it's based out of our to-do sample app, which is the main tutorial we have in the documentation. But we're actually going to use it in a Swift playground. So I'm just going to pull the room real quick. Who's specifically Android focused? Okay. And what about Windows? Okay, so there's only going to be about 6 of you disappointed to know we'll do iOS, but it's very similar in other languages, right? So don't worry. So we'll talk about creating a database, opening an existing one using CRUD, the threading model, the query API that's changed so much, the Blob, so that's basically attachments, but with a few changes, replication, that's also changed a lot, and conflict resolution. I've put a DP tag at the top just to say that everything we talk about today is in developer preview. Actually, the way we release the updates to the users is through developer builds, and we usually release a new one every 2 weeks. And so in the documentation, you'll find that we say when we're releasing a specific developer build, and then the release notes for that developer build and the documentation. Okay, so back to the scenario. So the to-do sample app is I'm just going to recap this for everyone in case some people are new, but it's a multi-user list to-do sharing list application. So the users can log in, they can create lists, and notice the count that says 20 here. That's a query that's a bit complex because you need to basically, you need to query all the tasks and know which list they belong to, and then group them by the list they belong to. So that's an aggregate query, for example. And then you can obviously edit or delete lists. You also have in each list the ability to add images and to check them off. And on the third screen on the right, you can actually search for tasks. So that search is done using prefix matching in the 1.x API, but in 2.0 we have full text search, so it's a bit obviously more powerful. And the reason I've chosen to use Swift Playgrounds is because it's going to be really easy to show you what the result is of a specific operation, that it's actually working, as opposed to pasting some code in slides that you wouldn't know if it's going to work or not. So that way the proof is there. And it's lightweight, so you can actually download this from the documentation later. Right here, Swift Playgrounds, and try it out. Okay. So when you open that Swift Playground, you will find a small Getting Started section, which tells us to download a pre-built database, which is called todo.cblite2. Then after that, so it's a 1.x database, and we're going to use 2.0. So we'll see that it automatically upgrades it for us. But it's telling us to put that database in the documents/shared playground data directory. I'm just going to do that real quick. Okay, that's that. And to unzip the file, okay, that's what we did. And now we can dive into it. So the first thing is creating a database. A database is a simple collection of documents. You can have multiple databases in your app. Usually, like when a user logs in, if you have user login, then you could use the database, the username as the database name, so that when you log out, the database is still there, and if the user logs in 2 weeks later, the data is still there. So you can use different databases. That's fine. But in the 1.x API, you would have had to use the manager class to create a database. And the manager now is not available in the 2.x API. Instead, you use the database initializer. So this line here, I'm going to make this bigger. Okay, so this line here takes a name, and that's it. So let's run it. Let's see where the database gets persisted. Oops. Okay, so that's like the container where it will persist files by default in a Swift playground, but that's not where we downloaded the to-do.cb Lite file to. So we're going to use another initializer, which is it takes a name and also an options parameter. Okay. So the options parameter is the database options type. So you can instantiate a new instance and then set the directory on it. You can set other properties like read-only, the logging level, if you want to which particular logging you want to have in the logs, and you pass the options to the initializer. Now, if we call database.path, so notice here the options.directory as the value takes the documents directory.path, which is this folder where we pasted the to-do.cblite2 file. Okay, so, and now we see that the path is in the documents folder. We can iterate over all the documents in the database. So there's a all documents method, and print the document ID and the type for every document type. Okay. So all those documents of type task and task list are the ones from that screen. And yeah, that's basically a lot simpler to create a database now. What about creating documents? So similarly to the database, the documents also have initializers now. So it's the same pattern for database and documents. And there are different initializers. Some you can pass a dictionary, which is your document, or you can pass an ID and a dictionary if you want to create the ID yourself. In this case, it's the database that's going to create the ID. And the document properties are the type, the owner, and there's a date. And yeah, we see that the save method is now on the database object. So previously in 1.x, you had to call document.putProperties, but instead now the way you save a document is on the database object. Something else to note is that in 1.x there was a getDocument method which would return, it was a get or create. So if the doc ID, you would specify get document by ID, and if the document didn't exist, it would create an instance for you. In 2.0, get document will return nil if the document, if this document doesn't exist. So instead you have to create it explicitly with the document initializers. And the toDictionary method is just a convenience method if you want to quickly print the, convert it to a dictionary and print the results to the console. Okay, let's update that task because it's actually missing a property here. It's a task, but it's missing its name, right? So how do we do that? In 1.x, to update a document, you typically would create a mutable instance of the document properties and then modify them and pass them back to the document. But in 2.0, the properties are mutable by default, so you don't need to do that copy, and you can change them in place. So the same new task instance has a setter method which can take any key, any string as a key, and any JSON valid type as a value. In this case, it's just going to be a string. And the document gets updated. It's getting saved twice, but that's fine. And we see the name there. Now let's get a bit more fancy. Let's say that instead of having task documents and list documents separately, let's say that we want to embed them. So the first line creates a new document with the dictionary holding the name and the type, which is a task list, right? And straight away after that, we call the setter method to set a new property like the tasks and as a value an empty array. And right after that, we call getArray on that tasks and we add a new item. So it's an array, and inside of the array there's a dictionary. And right after that, we call the add method again to add another item. So a spade and a sandpit. And yeah, that was just one line essentially, but because the API is chainable, you can just carry on adding your properties. So if in your app you decide to have a base object, and at some point later, if the user clicks on an option to add this property in, you know, it's very easy. You just plug this to the UI actions and then add or remove the values. And right at the end, you call database save, and the new list.getArray, which is the tasks, right? The tasks array. The count is going to be 2 because we added two items. So that was the document API, which has changed a fair amount since the 1.x API. All of that is in the documentation, as I said. So if we're especially looking for feedback on, you know, how you're finding it, if you're finding it easy to use or not, and by far the biggest change is going to be the query API, which I'm going to show you now. So in 1.x, indexing was done through views. A view is like in Couchbase Server, a map reduce, a definition, which is used to index documents at write time. And yeah, it was quite powerful. You can do aggregation using map reduce. In 2.0, so in 2.0, we actually changed this concept completely. And instead, we are using a new query language. To query, you have to create an index. It's optional. So here, database.createIndex, and the property we want to index on is the type. Once you have an index, you can create a query. So in 1.x, you had to create a view to query it, but a view object. But in 2.x, you don't have to create an index necessarily. I'm just showing here the definition, but you don't have to. If you don't want to create an index, you don't have to. It'll just be slower result time. So the query API is cross-platform. So the definition of a specific operation is the same across all platforms. And here we have it. The query class is again a chainable class, and you can call a select statement on it, and then the from statement, and specify which database you want to query from. And at the end, you can say where the expression, so where the type property, expression property type is just like saying where type equal task list. And so the index we created above is also on the type. So if we run this and we can iterate over the results, but we could also use the .explain method to have a query plan of what happened when the query ran. So that query plan is saying that the where clause is matching on the body, on the type property equal to task list. And on the last line in the middle, you can see it's specifying using index. So it is using an index. Now let's create a similar query that matches on the name property, and we haven't created an index to match on the name property. So the explain statement should be different in that case. And yeah, here it's telling us it's a scan table, so it's a full table scan of the database to match on the name property. Whereas previously it was matching on the type, and we had the index for that. That's a quick way to know if your query is using an index, but don't use those strings to in your application to pass. Don't pass those strings in your application, because those could change. It's just for debugging purposes. And yeah, those were two simple examples, but the talk later on at 4 o'clock is going to dive into more examples for query and full text search. Okay, the Blob API in 1.x was accessible through the revision API. And in 2.x, the revision API is completely removed. And Blob is treated as a top-level entity, just like any other JSON valid type. So let's say we created a croissant, which Swift Playground displays nicely for us here. This is actually a UI image. And then we convert this into a data type. So to pass this blob on our new task instance, we first initialize it as a blob and passing the content type, the image, JPEG, and the data. We can also use an initializer which will accept an input stream, so you can use one or the other. And the set property takes the key, the attachment name, and the value is the blob. So that could be a string, or it could be a blob, or it could be an integer, a boolean, or a date, or an array, or anything as well. And so we see that the key image has a value, and that's a dictionary with an underscore CBL type. That's how Couchbase Lite knows that this is an image, an attachment. And what else is there? Yeah, a digest. That's how Couchbase Lite can tell if the attachment has changed, and the content type. So let's see where that was persisted in the database. The underlying storage engine in 2.0 is SQLite, and attachments are persisted in another folder outside of the database on the file system itself. And those are all the attachments that were in the 1.x API and then now available in the 2.0 that was upgraded. So we should find the croissant if we, oh, here it is. Yeah, so everything's working. Okay. Typed accesses. So in 1.x, we didn't really have typed accesses. So when you accessed something, you would have to cast it to the type you expect it to be. In 2.0, that's simpler because with a type accessor, if it's not of that type, then it returns nil. So you don't need to do the nil checking in the application. So that new task has a name and a created at, and we see that if we print the created at, it's automatically returned as a date object in Swift and printed nicely. So the definition of this get is to return a date. And there's also one for attachments. So get blob, and yeah, that's a lot simpler than the 1.x API. In 1.x, you would have had to go through the revision API, get attachment, you know. But in 2.0, just like any other type, just get blob. So here it is. Okay, and the last feature, which is pretty useful, replication. In 1.x, push-pull replication methods had to be called to create bidirectional sync. But in 2.0, you just have to call one method called the replication, and that will enable a push and a pull, because we saw that a lot of people were always using push and pull, so why not make it simpler? But if you want to have just push or just pull, you can also, there's other methods available to just initiate one side. Okay, so to show you that's working, I'll start. Okay, that's Syn Gateway up and running, and the config file for that is pretty basic. I'll show it. I'll show it afterwards. But if we run that method, so let's open Syn Gateway on the browser. So there are document type is yeah. There's a fair amount of them. Yeah, there's 31,000 documents. But let's add a few more. I'm just going to add this line here because the playgrounds by default don't carry on running when there's an asynchronous task. So replication is asynchronous. So we need to explicitly tell playgrounds to continuously run even when the last line has been executed. So if we reload that page, that was 92. Now it's 31,628. So yeah, that's how you can enable the replication. And the reason it's actually the logging is carrying on right now is because the replication is bidirectional. So the 31,000 documents on the server side are getting replicated in the to-do database, and we should see that that database is growing in size. Let's have a look. So yeah, six megabytes. I think it was, yeah, much smaller before. Okay, I'm just going to stop this because it's getting annoying. The last thing is conflict resolvers. So that's tied very much tied to the replication concept, because if you have two devices that are both offline and they make changes and then they synchronize, they make changes, different changes to the same document, both synchronize. When they come online, the system doesn't know what to do. I mean, it's going to pick a winner and it's going to return it to your application, but it doesn't do the maths for you. You have to know what your business rules are to resolve the conflict. So, you know, think of it as a Google document. If two users make a change and a user has a special privilege, then maybe that user's change overrides the other one. That's something you have to implement in the application using the conflict resolution API on the 1.x API. In 2.0, the underlying revisions concept, as I said, is not there anymore, so there's no revisions API. And instead of deferring the resolution of conflicts to the application, it's proactively done at replication time as soon as documents get replicated. And the reason for that is because you may not want to resolve the conflict straight away. It's possibly going to become a problem as it grows in size and you get more and more conflicts. So it won't be a problem to the end user, but actually storage-wise, it's going to grow and grow and grow. So that way in 2.0, because conflicts are resolved straight away, it's never going to be a problem. And there's a default way of resolving conflicts, which is to take the one that's had the most updates made to it. But there's also an API to override that and customize it. And so when the replication detects there's a conflict, it's then could call a method into your application, passing the properties that it received from the server, the ones that your application made the change to, and then in the application code, you can say how you want to resolve this, return the result, and then that gets resolved at the database level. So that's the end of this playground. Later on today, we'll be doing a similar walkthrough for specifically the query API and the FTS query, which is going to be based on an entirely different data set. It's going to be based on the travel sample data, which is a bunch of airline routes. A lot of the data is a lot richer, so it's easier to run queries on it that are a bit complex. And full text search. And both of those playgrounds are available on the docs. You can, as I said, we're always looking for feedback on the developer builds. There's going to be, I think in the room there's a couple of people who are involved in the 2.0 API, so if you have any questions, Sachin is there. He's your man. Other than that, yeah. My name's James. I work at Couchbase as a tech writer, and that's my email. The link below is the documentation link. And I'll leave that slide as the last slide. And yeah, thanks a lot. Is anyone using the 1.x API currently? Okay. One? Anyone else? Okay. So definitely interested to know your thoughts on it, and if you haven't tried it yet, then for you to give it a go. For the sync? Yeah, it's using a totally different replication protocol, which has been developed based on the improvements we found in the 1.x version of it. It's using native WebSockets. I can't tell you much more about the underlying function of it, but I mean, Sachin will probably know a bit more about it. Yeah, it's transparent to the application, Oh yeah, one thing that's quite big about it is that it's going to support delta compression. So if you have changes made to your documents, it's only going to replicate those changes as opposed to all of the document. So yeah, you know, if you have a document with all of the data on that document, it's not so much of a problem because it's going to replicate only the changes. Which coincidentally makes it easier to develop a sync function, because if you have one document that has everything into it, you can write a sync function pretty easily. Whereas if you have lots of smaller documents, writing a sync function is a bit more tricky. But it's totally unrelated. There's two different things.